Today, we will discuss the concept of coordinate geometry. It is a system of geometry in which every individual point in a plane is represented by two individual values. So what are those two individual values? I'll explain you in detail. So before that, we should split the total plane into four individual parts by using two lines which are known as x-axis and y-axis respectively. So the point of intersection of this x-axis as well as y-axis is known as origin, which is represented by 0, 0, and the first one is known as x coordinate and the second point is known as y coordinate. Right. X coordinate can also be called as abscissa and y coordinate is known as ordinate. I'll tell you what is this x coordinate and y coordinate. So, as we were discussing how to represent a point or how do you know the value or how to represent a point in individual quadrants. Suppose that there is a point 2, 3 here. So, how do you know that this point is 2, 3? We can tell that this point is 2, 3 by knowing its distance, that point's distance from the respective x-axis as well as from the y-axis. Now, the x value or the x coordinate represents the perpendicular distance from the y-axis. So obviously, because that this particular distance is 2 units, so obviously a parallel line will have the same distance. So obviously this is 2 units. Next. Similarly, so in this way you have got the x coordinate. Similarly, for the y coordinate means that the perpendicular distance from the x-axis. So obviously this is of 3 units. So in this way, a point is represented in any individual quadrant. So suppose that if you want to represent a point in second quadrant. So in the second quadrant, you have x values all to be negative as well as y values all to be positive. So suppose that you want to represent a point here. So obviously, because that the x coordinate is nothing but the perpendicular distance from y-axis, its value is of 2 units. Its distance is 2 units. But the point, in order to mention that the point is in the second quadrant, we have to give it a value -2. Similarly, because that the y-axis or the complete y-axis which is present upper side is all positive, that is the reason we are considering +3 here. Similarly, if you want to denote a point in the third quadrant, you can denote that because both of them are obviously negative. So obviously you have to denote that with -2, -3. Similarly, here also you have 2, -3. Okay, right. So after this, how do you denote a point lying on the individual axis? Yeah. So now, how do you represent a point lying on the x-axis? So how do you represent that? Suppose that we have to consider. So this point has some perpendicular distance from the y-axis. So perpendicular distance from the y-axis, it is the x coordinate. So that is the reason it has some x value. But what about the perpendicular distance for a point lying on the x-axis? Obviously there will not be any distance. So that is the reason we consider that value to be 0. Similarly, for a point lying on the y-axis, it will be represented with 0, y. Okay. And next is that the distance between two individual points lying in the plane. So how do you represent that? Suppose that there is a point x1, y1 here. Similarly, there is one more point x2, y2 here. Okay. So what would be the distance between these 2 points? The distance between these 2 points is represented with under root of x2 minus x1 whole square plus y2 minus y1 whole square. So the distance always will be positive for whatever might be the value. That is, if x2 is greater than x1 or x1 is greater than x2, definitely the complete value is squared. So the value what you are getting is nothing but a positive value. Okay. So let us see how to find the distance between 2 points. There are 2 points, A 4, 2, B 7, 5. So the distance is as per the previous formula, that is x2 minus x1 whole square plus y2 minus y1 whole square. So in these 2 points, you can consider either of them to be x1 y1 as well as x2 y2. That doesn't matter, because see, you are considering here the difference of them, which is squared. Suppose that if you have considered x1 y1 and x2 y2. So if you interchange also, there will not be any problem. So under root of 7 minus 4 whole square plus 5 minus 2 whole square. So which will give you under root, suppose if this is interchange, what that could be? Under root of 4 minus 7 whole square plus 2 minus 5 whole square. So which will give you a negative value, but which when squared, definitely it would become positive. So there will not be any change of the distance between the 2 points if you have interchanged both of them. Okay. So that gives you an answer of 7 minus 4 is 3. So 3 square plus 5 minus 2 whole square is also 3 square. So 3 square is 9. So under root of 9 plus 9, which will give you root 18. So root 18 can be written like 9 into 2. So square root of 9 is 3. So 3 root 2 units.